Now come to discuss data-centered software architecture. This is the next category of software architecture. In our previous lecture, we talked about the data flow architecture, batch sequential and pipe and filter architecture patterns. Now, what is data center software architecture? Centralized data store that is shared by surrounding software components. The previous pattern was about how data flow, either in a sequence, either it support concurrency or not. But here this pattern shows how data is stored. So software is decomposed into two major partitions: data storing or data stored element or partition, and software agents components. Remember that software consists of different components and there is associated data store where the data is either inserted or retrieved to different components. Pure data center software architecture. What is pure data center architecture software architecture? Where all the communication is through repository. Repository means a database where data lies. The two broad categories of data center architecture are repository and blackboard. So there are further two categories inside the data center architecture. Either it will be the repository data center software architecture or the blackboard. Repository data center software application is also known as the passive data store, and the blackboard is also known as the active data store. Why it is called passive and why it is called active? So it will be discussed in detail shortly. You can see this figure. There is a data stored and we have agents. Agents consist of different software components. So the same component can be mostly each agent contains the different components from other agents. So here the components or the modules, sometimes we talk about component and sometimes we talk about modules, so I am explaining it. So if I talk about the module, this means I will talk about the whole components which purpose is for particular goal, and one module consists of one to several components. So we can deploy or install the different modules on different agent sites. For example, agent 1 contain one module, agent 2 contain other module, agent 3 contain other module. Or we can decompose or distribute some components on one agent system and some on other system. If the module is quite large, such that it contains submodules or components, several components, so different approaches can be used, but it does not differentiate either it is a repository or blackboard. So let's talk about in detail about the repository and blackboard. This is a generic feature where this is a client software. Agent is also known as a client. So client software is installed and data stored. So it can be either repository or blackboard. Now come to discuss the repository architecture style. A repository is a shared data store. Shared data store means that this data store is shared among the different agents. Supports the user interaction. Clients can get data from this data store and put data in again in the data store. This means the clients, users on the client side, agent side can retrieve the data, and then after processing or manipulating data, then data can be goes back to the data servers or storage devices. It is a very common approach in information systems where data is shared among different functions. All the clients are not necessarily completely independent. As I stated earlier, that it is not necessary that the modules that we will always install the different modules on different agents, but same module components can be distributed on different agents. So here this is a repository which is a centralized data store, and all the agents are given rights to store their data in the same repository or database, and these end user approach or connect to agents through the front end graphical user interface. Now talk about in more detail using the patient database system. Most commonly, this architecture is used when large amount of data are to be shared. But remember that it is not necessary that we must have a large amount of data. Problem that fit this style have the following properties. Number one, all the functionality work of a shared data store, all the functionalities either belong to one particular module or one agent or many agents. So all the agents share or approach to one database. Number second, any change to data store may affect all or some of the functions. Obviously, as all the agents approach to the same data store, so this means change or modification in data storing data can affect the rest of the agents. All the functionality needs the information from the data store. So this means here you can see that patient database and the 4 modules are installed on different agents. Physician diagnosis, which is, and the user doctors are connected to this agent. Another module is a pharmacy and drug processing, accounting and administration, and lab testing. So normally these 4 modules are installed on different sites. Whenever physician diagnoses a patient, the data will come here and will be stored in the patient database. And other modules, agents or users can see this physician data. Not all data. Remember that we can put some constraints. Remember that if there is some privacy on one agent side, so this means we will assure that privacy. And this means that all the rest module cannot see the whole data, but if we want to put back the constraints so they all then can see. But the data goes to the same database. Why this approach is adopted? Because if you go to the accounting section, you pay there, or they give you a deposit slip, you go to some other section, bank, etc., and then deposit money. So accounting department depend on the physician diagnosis. Obviously there must be some doctor fees. Pharmacy means patient must, if the patient have taken some drugs, medicines, and other fees are also included, like operation theater fees, bed fees, room fees, other maintenance fees. And obviously if lab management conducted some blood tests, so there must be some amount the patients or their relatives must have to pay. So this means all the data from lab testing, physician diagnosis, pharmacy comes here, and then accounting department issue a receipt from the same data. Similarly, pharmacy and drug processing can issue the drugs based on the physician diagnosis. So where the pharmacist or this department take data from the same database where this physician is connected. Now the question arises, why it is called the passive data? Because the database here or the storing device here is not active. It is only used, the repository is only used to store the data. Only to store the data. There is no active controller there. There is no program installed that can automatically process the data. The agent are active. Agent initiate some process, and then based on that process, the data process passes, executed, retrieved, deleted, updated, etc. Passive repository based architecture is simply a central place to store application source code and information which is used only to compile the application program. It allows information to be reused when compiling the application, as I explained on the example, has a limit benefits to the application developer. Active repository or blackboard architecture, which is the next second category, are used in both the building and execution of the applications. So developers and application mostly rely on this active repository where the database or data storing is active, and the agents are passive. Agents are in active repository or in blackboard. The agents are just used for input data and to show the output data to the user. There is no active program installed on the agent side, or the components are passive, and the data store device or database is active. The algorithms, the controllers, or the instructions are active in this repository, active repository or blackboard. Active repository is a dynamic, and it is used when the application executes. Changes made to the data store can immediately reflect it in the application without having to rebuild code application. The application domain of repository architecture, normally relational database management system, follow this approach. Database system with data repository. Here you can see this is a centralized data repository, and all the instructions like delete, retrieve, update, insertion take place on agent side. So agents initiate these instructions, and then based on those instructions, data are either updated, inserted, deleted, or retrieved. Variant of repository, either repository can be virtual repository or distributed or decentralized. In distributed databases or distributed repository or decentralized repository, all the data are distributed over the link site, over all the site linked by the network. So network connect the different databases. Sometimes due to the network, due to some network infrastructure issues, or the users are too much, so maintaining one central database become difficult, data storing become difficult. So what they do, what the architect do, the architect distribute database into different databases, small databases. For example, banking system, if you take example of banking system, so every bank has some of not all but some of banking branches have their own local databases, and all the databases are either linked to each other or linked to the centralized databases. So for efficiency or performance, normally distributed databases approach is used, that is more scalable. And virtual repository, where there is a one database, central database. This is not decentralized but a centralized database where all the agents are directly linked to that repository rather than decentralized approach. Now there are some associated benefits and limitation of repository architecture style. Benefits include data integrity, easy to backup and restore. Why? Because of the one data store repository, so backup become easier. System scalability and reusability of agents. Agents can be easily replaced and can be reused. Remember one thing, reused. And scalability means we can increase the number of agents. There is no restriction. Agent can be one, can be two, up to several agents. So there is no limitations. So we can increase the number of agents, we can decrease the number of agents, we can replace the number of agents. You have seen from the patient database system that every agent is an independent thing. So if we don't need it, so we can replace without affecting the rest of agents. So this means that each agent is independent of the other. Yes, data is shared, data is common, data can be common, data is shared, not all, but some of data is shared. All data can also be shared, but the agents are independent. So the benefit is scalability and reusability of agents. It reduces the overhead of transient data between the software components, because normally the approach adopted is that we have centralized one database. So we can move toward the decentralized approach, but at the end that also process their data and enter data into one database. But normally transient approach is not adopt here, and data come directly to the one database. And one more example I would like to explain, that for example, if you have a bank account in some city and you go to some other city using the same bank but different branch in other city, so they can see your data. So how? Because the database is centralized, the repository is centralized, so anywhere when you go to the same bank but other branch, so they can see your data, you can deposit and you can withdraw your money, and then the same centralized database is updated. The limitations: the data store reliability and availability are the important issue, because all the agents rely on the one database. So if there is database issue occurs, so all the agents will be unable to retrieve or approach their database. So availability can become issue. If there is a network issue, so this also means agents become face difficulty to connect to that repository. Reliability issue, although it is scalable, but reliability issue can arise. Centralized repository is vulnerable to failure compared to distributed repository with data replication. High dependency between the data structure of data store and its agents. So this is the limitation, that there is a strong dependency between the data store and agent. And as transient data is not available, so this means there is strong link between the centralized database and the agent, and this can cause the issues. Cost of moving data on network. You know that for this architecture we need a strong network devices, so that become the costly. So that was all about the repository architecture style.